Okay, so let's recall. Solving equations. We have 4 steps. Find the LCM, distribute to every term, clear denominators, solve. What's the difference between a linear, where x has an exponent of 1, and a quadratic where x has an exponent of 2? What are the differences between those two? Okay, one is x squared, one is x to the 1, but what does that tell us? Let's hear it. One you have to what? One you have to factor. The other one is inverse operations, but what does that tell us? Yes? Oh, I'm getting all kinds of stuff. You graph this one, it's a straight line. If I graph this one, it would be a parabola, right? Oops, let's do this. Straight line and a parabola. All my colors are screwed up. Okay, this one can have as many as 2 solutions when we factor. This one can only have 1 solution. Does this one have to have 2 solutions? No, it doesn't have to. What are some reasons why it wouldn't have 2 solutions? If they're both the same, that could be one reason, like a perfect square trinomial, perfect. What about another one? Another reason why you wouldn't. If we have a quadratic, normally we get 2 solutions. What would be another reason why you wouldn't have 2 solutions? You check to see if one of them is an excluded value. Perfect. Okay, let's move on. Excluded values give extraneous solutions. Charlie solved this equation. You don't have to do it. He already solved it for you. And got the answers x equals 2 and x equals -4. That's your answer, right here. The solution to the problem is this. He already did the work for you. What is or what are the correct solutions? Talk with your shoulder partner. Okay, so can somebody raise their hand and tell me which one of these is correct and why? Okay, Caden. Which one's right? 2 is an excluded value. If I plug 2 back in here, I would get 2 minus 2. What's 2 minus 2? 0. So when you substitute it back in, it gives you a 0 in the denominator, which is no good. Right? So therefore, this is not a solution. This is my only solution. Okay. So why don't you guys, let me pass out your papers. We'll do this one together. Then I'll have you guys try this one. Okay? All right, so the process is the same for every single one of them. So I have to find an LCM. I start with this denominator and I say, okay, I need to represent everybody in the denominator. Fortunately, all we have in the denominator here is B. I'm going to go over here now. So that's check. This one's done. Right? I'll put a little check right here. That one's done. What about this one? Do I need to write another B? No, I already have a B. That one's done too. I don't have anything there. So my LCM is just B. So what was my second step? Distribute it to everybody. Right? Give everybody a B. So I'm going to multiply everybody by B. When I do that, what goes away for this term? B and B, because B divided by B is 1. That's why we can get rid of it. It can be simplified. Right here, B divided by B is 1. We can get rid of that. I have now cleared my denominator, correct? Yes. I no longer have a denominator. So what's left over? 3B minus 4. What else? Minus everything up here. right? Would it be fair if I were only to say negative b and not just negative 7? That's not fair. Isn't it saying negative everybody? Well, let's make sure we give a negative to everybody then. I need a negative to b, and I need a negative to negative 7. What happens when I give a negative to b? Negative b. What happens when I give a negative to negative 7? Positive 7 equals what? B. 1b, or just b. Let's get rid of this. We don't have room for that. Okay. Now that I have this, just for purposes, well, I'll do that later. So how many b's do I have total right here? 2 b's. 3 b's minus a b makes 2 b's. Negative 4 and positive 7 makes positive 3 equals b. I've got a 2b over here and a b over here. Which one would be easier to move? 1b would be easier than moving 2 b's, right? So I'm going to subtract b from both sides. Let me change my color. Subtract b from both sides. So if I decide to put the b's over here, what should I do with this 3? Move it over there by doing inverse operation. So b equals negative 3. Is it easier now? Yes. All right. Try number 3. Can I do this? Why? Why? Why can't I do this? Because the top one is locked. It says C minus 2. So what about this one? Can I do this? No. It's a quantity. This is a whole, this number, these two go together. Does that help? Find the LCM. Show me on your desk. Okay, so we're still having confusion. I'm going to do the same process as I did over here. I started with this one. I said, I need a C. So here's a C. Check. Correct? What else do I need? C plus 2. And I think some of you are confused. So check. Do I have everybody I need? Yes. Now, the reason why you don't multiply this out and make it c squared plus 2c is because that's not going to help you. Right? We're trying to get rid of denominators here. If I multiply both sides of this by c squared plus 2c, does that help me clear that denominator? No. So you don't need to multiply it. You just leave it like this. I'm going to multiply both sides of my equation by what? C times c plus 2. C times c plus 2. When I multiply both sides of my equation by c times c plus 2, what goes away over here? C goes away. What goes away over here? C plus 2 goes away. I just cleared my denominator. It's gone. What am I left with? No. C plus 2. What else? C plus 2 times C minus 2 equals C plus 4. Anybody see something interesting there? Nobody sees it? It's the difference of 2 squares. If you didn't see that, you'd have to use a box and multiply or FOIL it, right? But luckily, somebody saw that's the difference of 2 squares. If Jesse, if that's the difference of 2 squares, then what is this? C squared minus 4. Oh, thank you. That would have been bad. I've got a C times C plus 4. So let's distribute. What do I get? C squared, that's kind of a funky looking C. C squared plus 4C. That's convenient. Does everybody understand how we got to this step here? Are we good? Okay, where do I go from now? Subtract C squared from both sides. That's really convenient. Why? Because they both cancel out. So this one goes away, and this one goes away. I should have done that over here too. This goes away, this goes away. Negative 4 equals 4C. Divide by 4, divide by 4. So C equals negative 1. What do I need? You know what? I missed something. What did I miss? Excluded values. What's the excluded value over here? 0. Do I have to worry about it? So excluded value is 0. It doesn't matter. You don't have to write that, but it's negative 3. I don't have to worry about it. What's the excluded value over here? 0 and negative 2. Does that matter? Well, I mean, it does, but does it make a difference? 0 and negative 2. Doesn't make any difference. I didn't get 0 or negative 2 for a solution, so I'm good. Moving on? Awesome. Why don't you guys try number 4? So let's find our LCM. 9. Why would I break up 9 to 3 times 3? Am I crazy? Why would I do that? What? Why would I break it up? Right? So because there's a 3 in here. So is 9 represented up there? I'm breaking it up because I see a 3 right here, guys. Right? So is 9 represented? Yes. Is 3 represented? Is there a 3 there? Right? Don't I already have a 3? Do I need another one? No, I got 2. Right, Frankie? Why would I want to put a third one up there? That would just complicate things. Would you be wrong if you put one up there? No. You're just going to make more work for yourself in the end. Does everybody understand why I don't need to write another 3 up there? Okay. Because 9, right? Okay. Does anybody see a 6 up there? How could we make it a 6 up there? Put a 2. You get it? If I put a 2 up there, now I've got a 6. Is 6 represented up there now? Yes. Now can you do it? What am I going to multiply everybody by? 3 times 3 times 2. Do it. 2, 1. All right, so if I multiply both sides, everybody by 3 times 3 times 2, 3 times 3 times 2, 3 times 3 times 2. What cancels here?
3 and 3.
3 and 3 and 9. What cancels here? 3 and 3. What cancels here? 3 and 2 and the 6. So I don't have a denominator anymore, correct? All right, what am I left with? 14y plus 6 equals 15y. Which would be easier to move? 15y's or 14y's? 14y's. What am I left with? Y equals 6. Let's go back and unveil this. Do we have any excluded values we need to worry about? No, we don't even have we don't have any variables in the denominator, right? We don't have any excluded values. So that's my answer. All right. What about this one? What should I do first? Take out an x. What do we call that? Factoring out an x. It's there's a GCF, right? So if I factor out an x, what's left over? X plus 3. So why don't we just right from the very get-go, let me take a picture of that. We'll just substitute it right away. How's that? Better? Now can you find an LCM? See what I did there? So somebody help me out. What's my LCM? Okay, let's do the same process. What is represented here? What do I have? An x. What else do I have over here? No. An x plus 3. Right? Because it's on lockdown. Right, Andrew? This whole thing is a number, right? It's a quantity. What about here? That one's done. What about here? We already have one. Do I need this? I don't need another one. What about x? It's already there. So my LCM is x times x plus 3. That's all that's necessary to clear out my denominator. Why don't you guys do it? Record. If I multiply everybody by x times x plus 3, this goes away, this goes away. X plus 3 goes away, x plus 3 goes away. X goes away, x goes away. No longer have a denominator, it's gone. What's left over? There's nothing here, right? But a 3. Whoops. So didn't make it flip. So I have a 3. What's left over here? Okay, good. You guys skipped a step though, right? Equals what? X plus 3. Finish this up. 3 plus x squared plus 2x equals x plus 3. Did you get that far? Mario? Did you get that from the way you did it? Okay. I think you're ahead of us. Yeah, I'm guessing you're ahead of us. Okay, so I think what you're saying is this is a quadratic, right? And since it's a quadratic, how do we solve quadratics? We factor them and set them equal to 0, right? So if I'm going to be setting this whole thing up to 0, what should I move? The x plus 3, right? So let's move the x plus 3. Is that what you were trying to say, Mario? Kind of? So if I subtract x from both sides, and I subtract 3 from both sides, what am I left with? X squared plus x equals 0. If it's not a trinomial, I can't use an x box, right? So what is the other method we use when we have? No. Don't need a box. What's our absolute #1 thing that we do before we factor? Greatest common factor. Does this have a greatest common factor? X. No. The reason I don't want to see it, Mario, I will look at it separately, is because I've been working really hard for everybody to consistently be doing each one of these problems the same way. If you try and show everybody a different way right now, I'm too afraid that we're going to lose people. Okay. Where did I lose you?
At the third step.
At the third step. This?
Yeah.
Don't they both have an X?
Yeah.
So can't I pull an X out? We've done this forever, guys. No? You don't see that X times X is X squared and X times 1 is X? It's distributing in reverse, right? It's undistributing, exactly. All right. So, where do I go from here? Set them both to 0. So X equals 0, and X plus 1 equals 0. Excuse me, equals 0. So X equals -1. Let's go back. Do I have any excluded values? Yes. What would my excluded values be? I did. Because you subtract 1 from both sides, you get X equals -1. Okay, so what are my excluded values? I heard them. 0, because X can't be 0, because if that was 0, that would make the whole thing 0, right? And what else? -3. Do we care? Isn't one of my solutions 0? So can X be 0? No. So my only answer, my only solution is -1. X plus 3. What? You don't have to do it first. Right? Why would you just have to make sure that you do it at the end. Okay, if I tell you 3 over X times X plus, please stop talking, guys. For this multiplication, if that was 0, the whole thing would be 0. Are we good? So everybody understands that this is the only solution, and why? Okay. But number 6.
Oh my God.
It's not that bad. It's pretty easy. You guys get scared, and then you stop, and then you get on your Xbox. I don't know. Yeah, 2 prints. Guys. Andrew, factor it for me. X and X and 11 and 1. Do 11 and 1 make 12? Yes. That's hard? That's not that hard. We've been doing it for months, guys. Months we've been doing this. You get all scared and you stop. So now, is it that bad? What's my LCM? X plus 11 and what? X plus 1. That's not that bad, right? So X plus 11 times X plus 1. I'm going to multiply everybody by that, right? X plus 11 times X plus 1. Oops. And X plus 11 times X plus 1. Somebody said they wanted to see the excluded values in the beginning. What are the excluded values? X cannot be -11 or -1. Perfect. All right, what gets canceled? What gets canceled here? X plus 11. What gets canceled here? All of it. What gets canceled here? X plus 1. So if this goes away, what am I left with? x plus 1 times 1, which is just x plus 1. What about here? Plus 6, nothing else, right? Equals 5 times x plus 11. So this is x plus 7 equals 5x plus 55. Now what? Subtract x. Subtract x.
Wouldn't it be easier to do it? No.
Nope. You always move the smaller x. It's just easier. Otherwise, you end up with a negative, and you gotta divide by a negative. All right. So, what is negative 55 and positive 7? 48.
Yeah.
Negative 48 equals 4x. So, if 4x is negative 48, how much is 1x? Negative 12. Is negative 12 one of my excluded values? Nope, so we're good.
Oh, well, I did it right next to it.
Yeah, you'll always get the same answer. It's just you had one more step for you, right? Yeah. So don't be afraid not to do it that way. It's just you're making more work for yourself. Okay. I think that's it for today.